Nuclear technology is often associated with images of destruction, triggering a collective sense of panic. Just like the fluorescent green energy bar in the cartoon, it gives people a mysterious and scary feeling. Welcome to today's discussion on nuclear technology. In recent decades, the mere mention of the word nuclear has conjured images of devastation, fear, and the unknown. The development and use of nuclear weapons have cast a shadow over the perception of nuclear technology. The devastating consequences of nuclear bombs from Hiroshima to the Cold War era have left an indelible mark on our collective consciousness. The fear of a nuclear apocalypse looms large. These images and stories understandably make us wary of anything associated with nuclear technology. However, it's essential to consider a different perspective, one that challenges our preconceived notions. Today, nuclear energy is most used to generate electricity. Nuclear power plants work on the principle of nuclear fission, a process in which one heavy nucleus splits into two or more smaller nuclei. This process is accompanied by the release of large amounts of energy. This energy is used to change water from liquid to vapor. The generation of steam drives a turbine generator set. The rotating turbine in a turbine generator turns a generator that converts mechanical energy into electrical energy. Water can also be powered by fossil energy. The use of fossil energy to generate electricity is like that of nuclear energy. But we all know the harm is carbon emissions due to the atmosphere. At the same time, if the same energy being produced, the fossil energy required to provide heat is far greater than nuclear energy. Just like Mr. Thomas Edison, before he found the most suitable tungsten filament for light bulbs, he also used many metal wires as substitutes. Nuclear energy is more suitable for today's world than fossil fuels because it is cleaner. The most important thing that scares humans about nuclear energy is its high intensity of radiation. But what is radiation? Radiation is the release of energy in the form of waves or particles. Its most familiar form is visible light, but this energy can vary in intensity. Low-energy radiation enables us to listen to the radio, use cell phones and microwave ovens. High-energy ultraviolet gamma and X-rays are powerful enough to cause changes at atomic level. To give a simple example, sunlight also contains radiation. When we bask in the sun on the beach, we are also exposed to radiation. Radiation is all around us, and not all of it is man-made. Look at fire, for example. The heat and light from a fire are forms of radiation. Sitting by a fireplace can be a delightful and cozy experience. Imagine the simple act of enjoying the warmth and light of a stove. As the flames dance and sway, they release not just light and heat, but a type of radiation called infrared radiation. This radiation, invisible to the naked eye, is a fundamental part of the electromagnetic spectrum and an integral part of our everyday experience. The key is understanding safe exposure levels. Just like too much sun exposure can lead to sunburn, excessive exposure to ionizing radiation can have health risks. But in moderation, both can be perfectly safe and even beneficial. In the 1980s, a nuclear accident occurred in Hull, USA. The accident began with a failure of the cooling system of the second reactor. But when you look more into it, you find that no one died at a 3-mile island, and most epidemiological studies found that it had no detectable health consequences. After 30 years, only 51 people died from the incident at Chernobyl, and scientific studies found few health risks. connected to radiation exposure after Fukushima. Compared with the fossil fuel, it shows how using coal, oil, natural gas, and biomass has killed 100 million people in the past 50 years. This was due to pollution created by the byproducts of burning fossil fuels. The World Health Organization explains that it's safer to work in a nuclear power plant than in a big city office, as the urban air pollution of ozone, sulfur dioxide, carbon monoxide, and nitrogen. A dioxide causes 7 million deaths annually. We go back to the radiation. Only 0.005% of the average American's yearly radiation dose comes from nuclear power. This is times less than a cross-country flight, 100 times less than what we get from coal, and about the same as eating 1 banana per year. Wait, so if I fear nuclear energy, I also must fear banana? But before you start imagining that you can mutate into a superhero by eating bananas, you need to know that you would have to eat tons of bananas at once to be harmed by radiation. Just like this dose of nuclear radiation actually won't have much impact. There's also this study showing that a CT scan of the abdomen involves about 10 times the radiation exposure that the average nuclear worker gets in a year, or that living in a big, polluted city increases your mortality risk by 2.8 times that of a Chernobyl cleaner. So what is happening? Is nuclear energy dangerous or safe? A Harvard study found that newer generations of nuclear reactors, particularly that is called pebble bed reactors, are designed so that a nuclear chain reaction cannot run away and cause a meltdown, even in the event of a complete failure of the reactor's machinery. And that with the advent of modern reactors, such as the pebble bed reactor, and careful selection of plant sites, nuclear accidents like the one in Fukushima are actually not possible. Nuclear energy is not as dangerous as we think. We can harness the power of nuclear energy to illuminate our path towards cleaner, more efficient, and safer energy solutions. So let's banish the notion of danger and welcome the promise that responsible nuclear energy holds a beacon guiding us towards a brighter and more sustainable tomorrow.